Hi everyone. So my name is Krishore. I'm a STEM ambassador here at QUT in my final year of mechatronics engineering. Or we got another person. And yeah, welcome to our Meet the Researchers talk. And today, before we get started, I would like to acknowledge the traditional owners as the First Nations owners of the lands where we're joining this event today. I think everyone here is on Turrbal and Yagara land. So we would like to pay respect to the elders, laws, customs, and creation spirits. And we acknowledge the important role Aboriginal and Torres Strait Islander people play within the QUT community, and that we've always been a place for teaching, research, and learning. And yeah, we acknowledge the Turrbal and Yagara as the First Nations owners of the lands where QUT now stands. Okay, so today's talk, we've got Dr. Jarrett and Dr. Muge, both to chat to you about what the work that they're doing. Just a bit of housekeeping before we get into it. I think I can see everyone's on mute, so that's perfect. If you had a question throughout the talk, feel free to pop it in the chat or raise your hand. Otherwise, we'll have question time at the end. So you'll have plenty of time if you wanted to have your questions asked at the end as well. So just a brief introduction, because there's actually a lot more to what Jarrett and Muge have done. But to kick it off, Dr. Jarrett is a senior lecturer in interaction design in the School of Design at the Creative Industries faculty at QUT. He has an educational background in illustration and information technology, and his main research interest areas are gestural and embodied interaction, participatory design, design robotics, and performance robotics. The main aim of his research is to find better ways for people to be able to interact with new interactive technologies. And he's also interested in finding better ways to involve people in the design process, such as employing prototypes, which are provocative prototypes, to spark discussion and debate. And I've done a bit of work with Jarrett as well in the past. And so with the design robotics, so it's very cool, the stuff that they're doing there. And we've also got Dr. Muge, and who is a creative maker and transdisciplinary designer specialized in advanced manufacturing, digital fabrication, and parametric design. She is one of the chief investigators of QUT's Design Robotics project and a design lead in ArmHub. In her career, she has worked with prominent architectural firms such as Zaha Hadid Architects, taught in several institutions, including AA visiting schools, published articles, gave interviews, and presented in many international conferences and exhibitions. She has also been awarded in multiple competitions and events on the future of architecture and the use of novel digital technologies. Currently, she is a senior lecturer in QUT Faculty of Engineering, Interior Architecture. And so without further ado, I'll pass it over to Jarrett and Muge. I'll give them access to control the screen. I think, Jarrett, you have control now. And
okay,
yeah, go for it. So stage now yours.
Thank you very much for the introduction, Krishore, and thank you everyone for joining us today. It's a real thrill to be able to talk about our research with you. We think that young, keen high school students are extremely important to the future of technology. So if you have questions about anything we talk about today, I would love to hear them and love to have a discussion with you as we go through the presentation or at the end of the presentation. So get your thinking caps on and think of some really tricky questions from me and Muge to answer. This picture that's on the screen at the moment is of a staircase from the University of Technology Sydney building. Business school building down in Sydney, and it's designed by a very famous architectural firm, Gehry Partners. And this firm is famous for adapting software from industries like aerospace and taking that software into the architectural realm and finding ways to use it to design completely kind of crazy, swoopy, curvy forms of architecture. Right, so this staircase, you can see it doesn't have like a straight line in the whole thing. It's all these amazing curves and bent pieces of metal all welded together. Now, I worked on a research project with Muge called Design Robotics, which was funded by the Innovative Manufacturing CRC, and we worked with our industry partner UAP. And UAP is a company that makes art and architectural elements. So they are actually the company that built this staircase. And for them, they have a real problem because the architect, Gary Partners, makes these amazing forms, and then they have to find a way to fabricate it. So they needed new ways of using robotics in their fabrication to make this kind of what we call mass customized manufacturing economically feasible. So that's the project that we've been working on. Now, if I click, does it move the slide, Chris Shaw? It's not, okay. So we've got a big research team from all sorts of different areas. And the main thing I would say here is that in the researchers on our project, we have people from architecture, people from interaction design, people from engineering, and people from business as well, all working together to think about how we could integrate these new technologies into our manufacturing partners' work. If we go to the next slide. So what we've been working on is the problem of polishing and finishing metal pieces that are cast. And what our partner does, they make a lot of sculptures actually. A lot of their work is around Brisbane. And when you make a sculpture, often the artist that creates that sculpture will hand carve a pattern for it, and then that gets cast in metal. And what happens in that process is, because when the metal is poured into the mold, it's very hot. As it cools and solidifies, the metal actually will shrink. It will shrink by up to sort of 3%. So the final piece that you get out of the casting process is never exactly the same as what you thought it was going to be at the start. There's always these little discrepancies. So we need to give our robot a way to visually scan and see the workpiece and then make a digital model of it that it can then use to drive a finishing process. We're also really interested in ways that robots and people can work together. In the middle picture, you can see a photograph of one of our collaborators, Matteo. He's an expert metal finisher at UAP, and he's working alongside a collaborative robot called the UR10. It's a robot that's more safe to be around than other big industrial robots. And we think that this is a really interesting area to explore how we could bring robots into people's everyday work. We'll go to the next slide.
Yep, if you click it, you should be able to.
Okay, okay. So this is a short video that shows the process of linishing alongside a robot. This was a project that we did in about 2 weeks actually, a commercial project for our industry partner where they couldn't find a machine anywhere in Australia that was big enough to linish this piece of metal. Linishing is a special metal finishing process where basically you sand lines into the workpiece. I was looking out for that sound. You sand lines into the workpiece. So we made a system where the robot would work alongside Matteo. Matteo would fix up the mistakes that the robot made, but it actually made this process feasible for them to do. So this is another example of robotic linishing, and here we've got a cast metal piece that we don't have a digital file for. We don't know what the shape of that piece is, and we needed to give our robot the ability to sense the force that's being applied downwards on the metal piece, and also using the vision scanning to build a rough digital model and then come in and actually linish it. And what we're doing here is using a standard tool that a person would use and attaching that to the end of the robot. So we have some creative applications that we've been playing with as well. We've done crazy things like getting a robot to play the piano. So we did this at an art exhibition. This is a big industrial robot and it actually plays the piano by pressing on the keys. Another one which Muge designed is actually a 3D printed vase that's printed by the robot. So imagine the 3D printing that you might have seen before, but blown up 10 times so we can print really large scale things. We've done things like created a robot that automatically draws your portrait. And if any of you went to the World Science Festival a couple of years ago, you may have been able to see this one. So that was really fun. And last year, with the Young Accelerators program, we explored using robots to do light painting. So light painting is a technique where you open the camera shutter and let it record the light over a period of time. And what we did was worked with the students to develop a LED strip that we could put on the end of our robot, and then as the robot moved that, we could do interesting data visualizations as if they were floating in the air. This is an example that Muge will talk about of our other creative work that we've been doing.
So this work is called Robotic Morphologies, and it's part of a design that we created for the Istanbul Design Biennale that was exhibited there. So as part of this project, if you could go to the next slide, we designed this web interface where users, any type of users that have no knowledge of using robots or design, could go in and play this game called Robotic Morphologies, which is based on the edge conditions of each tile. So you could design this pattern, and with the pattern you can play with its edges, the conditions, whether it's a smooth curve or a sharp curve. And then this web interface exports a file that goes into the, if you go to the next slide, and you can create different types of patterns. And if you go to the next slide, it just spits out this file, which is then inputted into a 3D design modeling tool called Rhino that mainly jewelry designers, industrial designers, and architects use to create these three-dimensional blocks, breeze blocks. And we are using a visual programming language to create the blocks which you have seen in the previous slide. Then this information is directly sent to the communicator to the robots. In this case, this was a KUKA robot that we controlled to cut these block pieces. We could go to the next slide. And this work was exhibited in Istanbul. So we worked on the code and we did some experiments here in Brisbane. And then we sent the code to Istanbul, where during the Biennale, so we had 2 weeks that the work was exhibited in a gallery space, where an industrial robot actually cut each of these blocks to create a pattern, which you can see in the next slide here. So the way we collaborate globally now is changing, so we can remotely control designs or have the control over digitally creating designs that could be manufactured anywhere in the world. Later on, we had exhibited this work as part of BAD, which is the Brisbane Art Design Festival. Actually, it's coming up this year again. So I really encourage you, if you're interested in design and what's happening in Brisbane, to attend the events of Brisbane Art Design. So we exhibited it last year in the main gallery, and this year we'll be showing some of the clay cut versions of those blocks. And for this year's Young Accelerator program, we are working on a new process, which is called incremental sheet forming. So at the end of this time, we attach this jeweler's tool to the robot, which is a metal pole that can go over the metal sheet to deform it incrementally, so that you can upload any image or any 3D shape, and then the robot can create them out of this aluminum foil. Usually incremental sheet forming is used in industry as creating mass customized molds for assembling various complex geometries. But by using a robot, you are actually allowing this process to be more efficient and more sustainable. So that's all I think we wanted to show. And if you would like to see more of our works, we can go to next slide, please. You can check our website, which we are working on to develop it further right now. And you can also email us through these emails.